Hey, Mr. Ang, I completed my math test. Good, but did you show your work? Oh, it looks like I didn't. Sounds like a 0 for you, young lady. Always show your work.
8.45, we're going to talk about the empirical rule. Okay, let's just do some basic definitions again. Right here in the middle of a normal curve is something called the mean. And we've talked about previously in a previous video, this is the mean for the population, and this one is called a sample mean with x bar. And then we talked about how standard deviation is here in green. Standard deviation. It is a measure of, they call it spread. How far apart is the data from the center? So I'm just going to call that spread. And in blue, mean is a measure of the center. Okay, I'm going to talk about the empirical rule, but before I do that, I want to mention one idea. Area under the curve equals 1. So basically we talked about this ghost, right? And if you shade this all in, that is equal to 1. Okay, so the big one is called the empirical rule. And in the empirical rule, 1 standard deviation, remember -1 standard deviation, the symbol for standard deviation is here with a O with a little tail, and positive standard deviation, positive just means you're going towards the right, is this area. Alright, so this whole area is a total of 68%. Let me shade that in with a yellow. So everything that I'm shading in here is 68%. Now, you need to know this. If the mean, the dark blue line, cuts it in half, that means each of these are 34%, because 34 plus 34 equals 68. So if I said how much of the data is 1 standard deviation above the mean, that would be towards the right, that would be 34%. If I said what is the area, what is the percentage of the area between 1 standard deviation, we talked about between is between 2 locations, that's -1 standard deviation plus 1 standard deviation, 34 plus 34 is 68. Okay, the next part of the empirical rule is within 2 standard deviations, so here again is the mean, this would be a +2, this would be a -2, and these numbers are always, so in empirical rule, always between 2 standard deviations. This area I forgot to draw the mean. So total, this whole area is going to be 95%. In red, the shaded red area. And if you divide 95 in half, you will get 47.5% each. So the left side is 47.5, the right side is 47.5, and you add the 2 reds together, you get 95%. Now, you might come into a situation that looks like this. Oops. Let's try that again. There's the center. And let's just say you're at if you know this blue region here represents 34%, then this green region, 47.5 minus 34 gives you 13.5. Why? Because the green area, if it's 13.5 and the blue area is 34, if you add those two together, you will get 47.5. So that, going that direction, remember, is 47.5. Okay? And let's do the last one. Let's do purple. The last one is within, from the center, 3 standard deviations. Let me count those out loud. 1, 2, 3 standard deviations. And if you go towards the left, 1, 2, 3. Basically up here. Let's shade that in some kind of color here. Let's choose green. So everything in green, this here represents, in green, 99.7%. So again, the empirical rule is 68, 95, 99.7. So let's just say you divide 99.7 in half. You divide it by 2. So 99.7 divided by 2 gives me 49.85. 49.85%. Okay, I do want to point out an area that we did not talk about is this area in red. These are called the tails. And we talked about how the area under the curve is 100%. And if I do it for this problem, let's say I subtract 99.7. That means the two tails together equals 0.3%. Together. The two reds. So 2 reds equals 0.3%. If you divide it by 2, you'll get one of these reds equals 0.15. So if you add up all these areas together, let me get a different color. Let me get you yellow. 0.15 plus 49.85 plus, that one's to say 49.85. That's what I didn't want. No. Let's try that again. Okay, so 0.15 plus 49.85 plus 49.85 plus 15 will give you 100%. Okay? So this is called the empirical rule. So basically in the next problem set, you're going to do the same thing. You're going to do the shading of region, and then you'll use the empirical rule and kind of divide them up to figure out the estimated percentage. All right, here's our example. A normal distribution has a mean. So again, the mean is a measure of center. It goes right in the middle. And then we're going to say our standard deviation is 6. And this is what it means. You can keep adding 6 this way, and you can keep subtracting 6 this way. And that would give us scores like 42 plus 6 would be 48, 54, 60, and then you're just going to subtract. So 6, 42 minus 6 would give me 36, 30, and 24. Okay, so it says find the range of values that represent the middle 95% of the distribution. 95%, remember, one standard deviation away would have been 68, but 2 standard deviations away is how much? 95%. So basically what we're trying to look for is around 2 standard deviations away. 1, 2, 1, 2. So that would be between 30 the middle 95% of the data is represented by the range of what numbers? Of 30 to 54. Okay, part B, what percent of the data will be greater than 36? So they want to know this side. Okay. Now, if you, let's use, I'm using green. If one standard deviation away, if this represents 68%, that means the other two regions are equal because it's symmetrical. So you can do like something like 2x plus 68 equals 100. So you subtract 68, got 2x equals 32, and then x equals 16. So this left side is 16%, and this side is 16%. But if you think about it, what I'm trying to find is that red region, right? So the yellow, I guess that's a bad way of coloring it. Yellow, let's write that, yellow plus red equals 1. And if you know the yellow is 16, you're trying to solve for the red, 0.16, and you subtract 0.16, you're going to get the red equals 84%, 0.84 or 84%. And a second way you know that is because you can just add 68 plus 16 gives you 84. Okay, go ahead and try number 7. You gotta draw out a picture, label everything, and then go ahead and press play when you're ready to see the problem. Alright, here is my normal distribution curve. That's the middle. 1, 2 standard deviations, 3 standard deviations away. My mean is 186.4. And this is going to be fun. You have a standard deviation of 48.9. So I'm going to add 48.9. I get 235.3. And then I'm going to add 48.9 again and get us 284.2. And then you add 48.9 again and you'll get 331.1. And then I'm going to go back from 186.4 and subtract 48.9 and get 137.5. And I'm going to subtract 48.9 again and get 88.6. And then subtract it one last time and we have 39.7. Okay, what range of values represents the middle 99.7%? So based off the empirical world, this is how many standard deviations away. This is 3 standard deviations away. Let me count them. Now it does not matter, it's kind of like the absolute value. It does not matter which way I go. You kind of have to go both. Ready? 1, 2, 3. From the center. 1, 2, 3. I'm just copying my sentence above. The middle 99.7% of data is represented by the range. What are those numbers? 39.7 to 333.1. Okay. What percent of data will be greater than 235.3? So they want to know the red region. And again, you can just use what we did above, but here in green, these two dots represents one standard deviation, so that's 68%. And then that's the x, that's the x. So again, you add all these up, 16% from here. Whoa, what is that thing? My ruler's attacking us, guys. Go away, go away. There. And that's 68, and then this one is 16%. So greater means going towards the right. That would be 16%. 16% of the data will be greater than 235.3. All right, what range of values is represented by the upper 2.5%? Okay, this one's tricky because it's not part of the empirical rule, but the closest one you can get to the empirical rule is what? Here in blue, right? This is 1, this is 2, 1, 2 standard deviations away. This represents 95%, the blue. So think of it as x plus 95 plus x, 95 plus 2x equals 100. So subtract it, 2x equals 5, that means x equals 2.5%. So that, what value though? The upper, so that means going towards the right, so it would be this number. These two numbers. Let's see, that says try again. The upper 2.5% of the data is between, we said that in yellow, 284.2 and 333.1.
I love math, so I'm here to remind, not to write in ink, but use pencil, because everyone makes mistakes, and everyone has those days. You know what I'm talking about? So yeah, don't write in ink.